السلام عليكم طلاب الأحبة. هذا فيديو للوحدة الثالثة من syllabus of chemistry of grade 12. نبدأ في الوحدة الثالثة electrochemistry, in which we are going to see electricity, how it is produced or consumed in galvanic or electrolytic cells, and we are going to go through Faraday laws and other stuff. Now let's start with the first idea. Here we have oxidation. What is oxidation? We can define oxidation as losing electrons. So oxidation is losing electrons, or we can say it is increasing the oxidation number. The oxidation number. For example, Mg will become Mg2 positive. Now, Mg from 0 to Mg2 positive, that is going to be increasing in the oxidation number. So, what causes this increase in oxidation number is losing electrons. When magnesium has 2 valence electrons, when it loses these 2 valence electrons, it will be Mg2 positive because it lost 2 electrons. On the other hand, let's see reduction. Reduction is the opposite of oxidation. When there is oxidation, there must be reduction. We can define reduction by gaining electrons, or we can say decreasing the oxidation number. For example, if we have copper 2 positive, it will become copper 0. Or if we have F2, this is 0, it will be F2F negative. Now from 0 to negative, the oxidation number decrease. From positive 2 to 0, the oxidation number decrease. What causes this decrease is gaining electrons. When copper 2 positive gains 2 electrons, its charge will decrease into 0. When fluorine, which is 0, gains electron, the electron is negative. If fluorine gains 1 electron, which is negative, the charge of fluorine will be negative. So we call this decreasing in the oxidation state. So this is what oxidation means. It is increasing in the oxidation number, or we can say it is losing electrons while reduction is gaining electrons, or we can say it is decreasing in the oxidation number. Let's see here. When we speak about oxidation and reduction, we have two meanings. If we look at oxidation, it comes from the word oxygen. So we have two meanings or two concepts of oxidation. We have the old concept, which means to combine with oxygen. When we add oxygen to an element or compound, we call it oxidation. But this is the old concept. Magnesium plus oxygen, magnesium oxide. This is old concept of oxidation. Carbon plus oxygen will give me carbon dioxide. Old concept of oxidation. The new concept here, it means losing or gaining electrons of oxidation and reduction means losing. Magnesium lost electrons, chlorine gained. So magnesium what happened to magnesium? Oxidation. So here as we can see, there is no oxygen in the equation. This is the new concept of oxidation. It can give you a question, says which of the following involve old concept of oxidation? You'll choose one of these which contain oxygen. Which of the following involves new concept of oxygen? You'll choose equation in which there is no oxygen, but there is increase and decrease in the oxidation numbers. Here, magnesium plus chlorine, magnesium chloride, sodium plus fluorine, sodium fluoride. No oxygen here, but it is oxidation reaction. Let's see here. Now, the oxidizing and reducing agent. Usually it asks us about which substance is oxidized, which substance is reduced, and it asks us about the oxidizing and the reducing agent. Calcium, if we look here, calcium is 0. Now in a compound it became 2 positive. Chlorine is 0. Now in this compound it is negative. What happened to calcium is oxidation. So oxidation. Oxidation. Calcium is oxidized. Chlorine. What happened to chlorine? Let's see. Chlorine from 0 to negative, what happened to it is a reduction. So when we speak about the substance which is oxidized or reduced, calcium is oxidized, chlorine is reduced. But if we speak about the agent, now look here, chlorine is reduced because of calcium. Calcium gave it 2 electrons. So calcium caused the reduction of chlorine. So we will call calcium reducing agent. Calcium itself is oxidized. It is oxidized. But it is a reducing agent. Chlorine, what happened to chlorine? What happened to chlorine is a reduction, so it is reduced. But it caused the oxidation of calcium, so it is oxidizing agent. Now let's just think about it like this. The substance which is oxidized, it is a reducing agent. The substance which is reduced, it is oxidizing agent. Here in the agent will be the opposite. If the substance is oxidized, it will be a reducing agent. If the substance is reduced, it will be oxidizing agent. Now here in this case, what is the oxidizing agent? Will be chlorine. What is the reducing agent? Will be calcium. Let's see if we flip the equation. It will be the same. Here, calcium to positive, chlorine negative. After the arrow, calcium is 0 and chlorine is 0. Now calcium from 2 positive to 0, what happened to it? Reduction. So it is oxidizing agent. Chlorine from negative to 0, what happened to chlorine is oxidation. So chlorine is not chlorine, it is the ion of chlorine and not calcium here. The ion of calcium is we say oxidizing agent, and here the ion of chlorine is reducing agent, because the ion of chlorine is the substance which is oxidized. Now calcium, it is to positive, will be after the arrow calcium 0. What happened to it? Reduction. If we look at chlorine to Cl negative, this is before the arrow, this is the ion of it, it became after the arrow to Cl negative 0. Now from negative to 0, what happened is oxidation, because the oxidation number increased from negative to 0. Now let's speak about redox. Redox reactions and non-redox reaction. When we speak about redox, reduction, oxidation. So these reactions in which oxidation and reduction are involved. Let's look at the equations and determine these equations are redox or not. Sometimes it gives you questions, which of the following is redox? Which of the following is non-redox? If we look at the first equation, let's see here, magnesium is 0. Magnesium after the arrow to positive. Chlorine before the arrow 0. Chlorine is negative. So magnesium is oxidized, chlorine is reduced. So this equation is redox. Let's look at the second equation. Zinc is 0. Zinc to positive. Hydrochloric acid, hydrogen is positive. Chlorine is negative. And this plus hydrogen will be 0. Now let's see here. Does this equation or reaction involve redox? Is it reduction and oxidation? Yes. Zinc is oxidized, hydrogen is reduced. Chlorine, nothing happened to chlorine, but it doesn't matter. As long as we have one element oxidized, one element reduced, this reaction is redox. We can say it is redox. Let's look at the third one here. Ag, silver, is positive 1. After the arrow, Ag is positive 1. Sodium here is positive 1. After the arrow, sodium is positive 1. Nitrate is negative 1. Nitrate here is negative 1. Chlorine is negative 1. Chlorine is negative 1. Did any one of them change, or do you see any change in the oxidation before and after the arrow? Positive 1, no change. Negative 1, no change. Positive 1, no change. Negative 1, no change. So this reaction is non-redox. because it did not involve oxidation and reduction. Let's see here the last equation here. Hydrogen positive. After the arrow, hydrogen is positive. Chlorine's negative. Chlorine's negative. Potassium positive. Potassium positive. So we cannot see change in the oxidation number. This equation is also non-redox. This is non-redox reaction. So we understand when it says, is it redox or not? Let's see here the questions. Now the questions, it tells you, it gives you a question and asks you to find the following in any equation or any question like this. It will ask you to find the oxidized substance or the reduced substance or the oxidizing agent or the reducing agent. If you look at this equation, let's see here. Zinc is 0. After the arrow, zinc is 2 positive. Let's see copper here is 2 positive. After the arrow, copper is 0. Sulfate, -2, we don't care about sulfate. Let's focus only in this equation on zinc and copper. Zinc, what happened to zinc? From 0 to positive. Oxidation. So it is reducing agent. Let's look at copper. Copper to positive to 0. From to positive to 0, what happened to it is reduction. The oxidation number went down. So what happened to copper is reduction. So it is oxidizing agent. Now the question will tell you, for example, the oxidized substance. We will look at the choices. The first step we should do, we cancel what is after the arrow, because what comes after the arrow is not oxidized substance, is not reduced substance, is not oxidizing agent, is not reducing agent. So the first thing, you should directly cancel what comes in the choices after the arrow. For example, zinc to positive. After the arrow, we will cancel the choice number 2. Let's see here. After the arrow, we have copper, which is 0, which is number 3. Also, we will cancel number 3. Now, our answer, if it tells us the oxidized substance, will be the oxidized substance number 1. So this the answer will be number 1. It tells us now here the reduced substance. The reduced substance will be number 4. If we look at copper from positive to 0, it is reduced, so the reduced substance is number 4. But if it tells you what is the oxidizing agent, we determine it down here. It is the copper also, so this will be number 4 as well. Let's see the question number 4. It says the reducing agent, we determined it to be zinc, so zinc, which is number 1, is the reducing agent. In the exam, you'll have questions like this, and you should choose one of these. Let's look at another equation here. Ag, let's say it is positive 1. After the arrow is 0. Mg, it is 0. After the arrow, it is 2 positive. Now nitrate, we don't care about it because nothing happened to it. Now let's see. Mg, from positive to 0, what happened to it? Reduction. So it is oxidizing agent. Now magnesium, from 0 to 2 positive, what happened to it is oxidation. So it will be reducing agent. Now we cancel what comes after the arrow. After the arrow, Mg to positive. Where is it? It is number 4. We cancel choice number 4. Then we cancel Ag0, which is Ag0 number 1. The answers will be here, either number 2 or number 3. If it tells us about what is the oxidized substance, we'll choose magnesium. If it tells us what is the reduced substance, we'll choose Ag. If it tells us what is the oxidizing agent, we will also choose Ag. If it tells us what is the reducing agent, we'll choose number 3, which is magnesium. So these are the answers. Let's look at equations. If it gives us in the exam equations with their oxidation numbers. Ni to positive. After the arrow, 0. So from 2 positive to 0, this is reduction. So it is oxidizing agent. Sn from 0 to 2 positive. This is what happened to it? Oxidation. So it is reducing agent. Now we will cancel what is after the arrow. Ni0 after the arrow, we will cancel it from the choices. This step is very important because sometimes you get confused. Should I choose the element which is in free state 0 or the element with a charge? So cancel what comes after the arrow. Sn to positive, where it is, this choice number 4. Now if the question tells you what is the reduced substance, you will choose Ni. If it tells you what is the oxidized, you'll choose Sn. If it tells you what is the oxidizing agent, you'll choose this one, Ni. If it tells you what is the oxidizing agent, you'll choose this one. If it tells you what is the reducing agent, now if the question says what is the oxidizing agent, you'll choose this one. If it tells you what is the reducing agent, you'll choose this one. Now let's see this example which has negative values here. Now let's see sodium is positive, iodine is negative, chlorine 0. Sodium is positive, chlorine is negative. The first positive, the second is negative here. Iodine is 0. Sodium from positive stays positive, nothing happens to it, so we don't care about it. Let's just erase what happened to it. We don't care about sodium. Imagine it is not there in the equation. Let's focus only on iodine and chlorine. Iodine from negative to 0. What happened from negative value to 0? It increased. So what happened to iodine is oxidation. So it will be reducing agent. Chlorine from 0 to negative. What happened to it? Decrease. So reduction. Here reduced. So it will be oxidizing agent. Now let's cancel what comes after the arrow. Here iodine, chlorine negative. Chlorine negative is number 4. Cancel it. Iodine 0, which is number 1. Cancel it. The answers for any question here, if it tells you what is the oxidized substance, you'll choose iodine. If it tells you what is the reduced substance, you'll choose chlorine in 0 state. If it tells you what is the reducing agent, you'll choose iodine ion. If it tells you what is the oxidized substance or the oxidizing agent, you'll see chlorine as well here. So these are the questions and these are the answers which can be for this question. Let's see here. Some questions gives you one element and another, and tells you this element, for example, magnesium is reducing agent with oxygen. We should use the electron configuration. The easier electron configuration, we say less. The shells will take, the first shell takes 2, the second takes 8, the third takes 8. Let's say like this. Now let's make the electron configuration of magnesium. It is 12. So the first shell 2, the second shell 2. How many left for us? 2. Now it has 2 in its outermost shell. Should it lose these 2 electrons or gain 6? Which is easier for magnesium? Is it easier to lose 2 and become 2 positive, or gain 6 and become 6 negative? No, actually losing 2 will be easier for magnesium. So magnesium will lose 2 electrons. Magnesium will be oxidized. So it will be reducing agent. Now oxygen will be, let's see here, oxygen 8 to 6. If we just make its electron configuration 2 6, which is easier for it? To lose 6 electrons and become 6 positive, or gain 2 electrons and become 2 negative? No, it is easier to gain 2 electrons. It will be reduced. It will be oxidizing agent. Now the question says Mg acts as a reducing agent. Is Mg reducing agent? Yes, this question should be true. Let's look at the second one here. Also, if this question tells you Act as oxidizing agent. Yes, it will be oxidizing agent with magnesium. The second question here says chlorine acts as reducing agent to sodium. Let's see. Chlorine. Let's make the electron configuration. 2, 8, 7. 17, which is the electrons of chlorine. 17. Is it going to lose 7 or gain 1? It will gain 1 electron. It will be reduced. It will be oxidizing agent. Sodium. Now we don't need to do that. It tells us chlorine is reducing agent. No, false. It is oxidizing agent, not reducing agent with sodium. Sodium will be oxidizing agent. Sodium will be reducing agent, and chlorine will be oxidizing agent. Let's look at the last question here. It says aluminium acts as oxidizing agent with fluorine. Let's see. Aluminium 2, 8, 3. Fluorine 2, 7. Fluorine gains 1 electron. It will be reduced. It will be oxidizing agent. Here, aluminium has 3 electrons. Which is easier, to lose 3 or to gain 5? Easier to lose 3 electrons. Now we should make these shells complete. 8, 8, 8. Now, if you have 1 electron, it will lose it. 2 electrons, it will lose it. 3 electrons, it will lose it. If you have 5 electrons, it will gain 3. If you have 6 electrons, it will gain 2. If you have 7 electrons, it will gain 1 to become full outermost shell. This aluminium has 3 valence electrons. Is it going to lose them or gain 5? No, lose is easier for aluminium to lose. Losing 3 electrons, it will be oxidized. It will be reducing agent. It tells you El is oxidizing agent. No, it is not oxidizing agent. It is reducing agent with fluorine. That is it. Now, this table shows us the oxidizing and reducing agent. This comes in questions in the ministry exam. It gives you one of these and asks you which of the following is reducing agent or which of the following is oxidizing agent. The reducing agent will choose the alkali metals like sodium, lithium, potassium. We'll choose iron sulfate, and we have anhydrous oxalic acid. We have hydrogen sulfide. We have sodium thiosulfite. We have hydrogen, and we have elements which have low electronegativity. We'll speak about electronegativity later. Here, the oxidizing agent, you have the halogens, you have potassium permanganate, you have potassium iodate, you have potassium bromate, you have potassium chlorate, you have potassium dichromate, you have manganese dioxide, oxygen, and you have the elements which have high electronegativity. This is like questions to practice. This is how the questions come. Magnesium plus chlorine, magnesium chloride. In this reaction, what is the oxidized substance? The oxidized substance is Mg. Number 1. What is the reduced substance? The reduced substance is Cl. It will be Cl2. What is the oxidizing agent? Oxidizing agent, the substance which is reduced, also Cl2. What is the reducing agent? Will be magnesium. If the equation is reversed, then it will be reversed, because magnesium here 2 positive, chlorine negative. From magnesium from 2 positive to 0, what happened to it? Reduction. Here it says what is the substance which is oxidized. Here we have chlorine negative. Chlorine negative number 4 is the oxidized substance. And the reduced substance will be Mg, which has 2 positive. Mg 2 positive, the reduced substance. The oxidizing agent will be Mg 2 positive. The reducing agent will be 2Cl negative. And the question after it, zinc from 0 to 2 positive, what happened to it? Oxidation. Copper from 2 positive to 0, what happened to it? Reduction. What is the reducing agent? The reducing agent which is oxidized, which is zinc. So number 9, the answer is 1. Copper, the last one here, copper from 0 to 2 positive, and here we have Ag from positive to 0. So what is the oxidizing agent? The oxidizing agent is the substance which is reduced, which is 2Ag positive. Now here we have 2Ag 0. No, this do not choose it. You should choose this 2Ag positive. This is the correct answer. Now the idea here which comes after is real or not real transfer of electrons. We have in some cases real transfer of electrons. In some cases we have not real transfer of electrons. In this cases, if we have ionic compounds, there is real transfer in ionic. What is ionic? Ionic compounds which are metal plus non-metal. If we have a metal and non-metal, this is ionic. Covalent, there is no real. In ionic, there is sharing of electrons, but here in ionic, we have like real transfer of electrons. For example, sodium, it has 1 valence electron. Chlorine has 1, 2, 3, 4, 5, 6, 7. Sodium will lose 1. Chlorine will gain 1. Now what happens? Sodium will lose 1, chlorine will gain 1. Now it will be, this is positive, this is negative. There is real transfer of electron. NaCl, there is real. Magnesium, for example, magnesium has 2 valence electrons, and we have oxygen 1, 2, 3, 4, 5, 6. Now what will happen here? These 2 electrons are going to transfer from magnesium to oxygen. Now magnesium is going to be 2 positive, oxygen is going to be 2 negative. The compound will be Mg. Oh, this is 2 positive, this is 2 negative, because there is real transfer of electrons. But in covalent compounds, there is no real transfer of electrons. If the element is non-metal plus non-metal, here no real of transfer of electrons. If the element, let's say, start with hydrogen, usually hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, sulfur, phosphorus, C, this is, and Se, these elements are non-metals. If the element starts with it, usually it is not true or real transfer of electrons, like H2O. Here H2O, we do not have real transfer of electrons. We have oxygen 1, 2, 3, 4, 5, 6, and we have hydrogen. Hydrogen will share here 1 electron, and hydrogen will share. They will share electrons. There is no true or real transfer of electrons. There are sharing. They share electrons, so sharing is caring. They will just share electrons, and there is no real transfer of electrons. Yes, they will be positive and negative, but this is according to which one is more electronegative to attract the electrons to its side. Now, for example, in this case, oxygen is more electronegative than hydrogen. Hydrogen will be positive and oxygen will be too negative, but it is not because true transfer of electrons happened between them. It is just sharing, but this oxygen is more electronegative, so it will attract the electrons more to its side. That is why it will be negative, and hydrogen will be positive. If we look at this question, in which of the following there is real transfer of electrons? Hydrogen, no. Non-metal, covalent, no. Carbon, non-metal. Oxygen, non-metal, no. There is no real transfer of electrons. Potassium is metal, and iodine is non-metal. So yes, this is the correct answer. Sulfur dioxide, sulfur and oxygen, non-metal, no true transfer of electrons. The correct answer is potassium iodide. Here, let's see this question. It says, in which of the following there is no real transfer of electrons? Magnesium here, metal, and bromine, non-metal. Yes, there is real transfer of electrons. If we look at the second one, aluminium is metal and oxygen non-metal, so there is real transfer of electron. Calcium is metal and oxygen is non-metal. So there is real transfer. Hydrogen and chlorine. Hydrogen is gas, chlorine is gas. When they combine to make hydrochloric acid, they will not non-metal. So here no real transfer of electrons in this compound. Now let's see how to calculate the oxidation numbers in different compounds. First, oxidation numbers in ionic compounds. Ionic compounds, the metal and non-metal. We have, for example, magnesium and chlorine. Magnesium here is the positive, it will be 2 positive, and chlorine will be 1 negative, because magnesium is divalent element and it is metal, so it will be positive and the non-metal will be negative. Here if we look at, we have metal, non-metal, the metal will be positive, the non-metal will be negative. And let's see another one, Na2O, this is metal, sodium will be 1 positive and oxygen will be 2 negative. We can determine the oxidation numbers from the elements and the subscript numbers. For example, if we look at this one, NaCl, MgCl2, AlCl3. Now we can know the oxidation number of sodium positive 1 and chlorine negative 1. Magnesium, because chlorine took 2, so it will be 2 positive and chlorine 1 negative. Because aluminium here 1 and chlorine is 3, so aluminium 3 positive and chlorine 1 negative. Sometimes we have elements like this one, FaCl2, FaCl3, we have copper 2O, we have copper O. Now let's look at the oxidation numbers of these elements here. Let's see the oxidation number of these elements, how we are going to find them. If you have iron, we have iron 2 and iron 3, but chlorine here 2, so this is iron 2 positive, chlorine negative 1. Here iron, the chlorine took 3, so this is Fa3 positive. Copper, we have copper 1 positive, we have copper 2 positive. Now oxygen is 2 negative and copper took 2, the oxidation of oxygen to balance the oxygen, so this means the copper here is 1 positive because oxygen took 1 and copper took 2, the oxidation of oxygen, so this one. But here we have 2 negative oxygen and we don't have numbers here, so they balance each other. This must be 2 positive, copper 2 positive. Let's see the oxidation number in covalent compounds. In covalent compounds, we have 2 nonmetals, but one of them will be more electronegative, so it will attract the electrons to it. For example, carbon dioxide here. Carbon dioxide, in carbon dioxide, oxygen is more electronegative than carbon, so it will be 2 negative, and carbon in this case will be 4 positive, because the electrons will be attracted to to oxygen. But if oxygen reacts with an element which is non-metal, which is more electronegative, then the more electronegative will be the negative and oxygen will be the positive, like this one, OF2. In this case, if you look here, fluorine is more electronegative. Why it is more electronegative? Because it has 7 valence electrons, that will be 7 valence electron, and oxygen has 6. Which of them is able to attract electrons easier? Which one needs less electrons to be full? Which one will be stable for lower number of electrons? That will be fluorine. Fluorine needs 1 to be 8, but oxygen needs 2. So which is more electronegative? Which one, if it gains easier electrons to be negative, that will be fluorine. So in this case, fluorine will be negative 1 and oxygen will be 2 positive. Look, oxygen is 2 negative here. If it comes first with an element which is more electronegative, it will be positive 2, while the other element will be here negative. So now we understand what is meant by electronegativity. Electronegativity is the ability to attract electrons Now, element which is more electronegative will attract electrons. When element attract electrons, it will be reduced, so it will be oxidizing agent. Elements with high electronegativity are strong oxidizing agent, while elements with low electronegativity will be reducing agent, not oxidizing agent. For example, sodium, it has 11 electrons. It will be, if we these electrons, 2 8 1, it has one valence electron. Is it going to lose one or gain 7? Which is easier? What is easier is to lose one. That is why it will be positive. It will be a reducing agent. It is low electronegative. It cannot be negative, because to be negative it needs to attract like 7 electrons to it. In case to be negative, in this case it will not be oxidizing agent, it will be reducing agent. Now let's see how we calculate the oxidation number of elements which have covalent bond with different electronegativity. We said the more electronegative becomes the negative, and the less electronegative will be the positive. Like what? Like, for example, here hydrogen HCl, and we have here like NaH. Chlorine is more electronegative, so it will be negative and hydrogen will be positive. In this case, hydrogen is more electronegative than sodium, so hydrogen will be negative and sodium will be positive. Hydrogen was in this case positive, but in this case it is negative. The same element can be positive or negative according to the element it combines with. Let's see in the second case, if we have atoms or molecules which have the same electronegativity. For example, if you have hydrogen has one valence electron, and hydrogen has one valence electron, the same electronegativity. When they combine, they will share electrons. No one can attract the electrons towards it, away from the other. So the oxidation number of elements which have the same electronegativity will be 0, because the electrons will not be attracted to either one of them. In this case, if you have Cl2, Br2, F2, N2, I2, all of these elements, diatomic molecules, the oxidation number of them is 0 because they have the same electronegativity. Let's see how to calculate the oxidation numbers in compounds. First of all, any free element, the oxidation number of any free element equals 0. If you have Fa iron, if you have magnesium, if you have sodium, any element which is in its free state, you will see the oxidation number of it is 0. Don't think about it. Now in simple ions, if we have, for example, MgCl2, we said this will be 2 positive, this will be negative. Let's see here, in neutral compounds, the oxidation number in neutral compounds will be 0. Now if we look at carbon dioxide equals 0. Why? Because oxygen 2 negative and carbon will be 4 positive, and 2, this will be 2 times 2, 4 positive. Now 4 negative and 4 positive equals 0. So any compound which is neutral, which does not have a charge, the oxidation number of it will be 0. Carbon dioxide, water, H2O, calcium carbonate, whatever compound does not have a charge, you will see equal 0, because all the ions will cancel each other, or they will balance each other. This is for positive, this is for negative. After all, it will equal 0. So any compound with no charge, it equal 0. Any polyatomic ions equal the charge. So any element with a charge, it equals the charge on it. For example, NH4 positive 1 equal 1 positive. Here nitrate negative equal negative 1. Hydroxide negative equals negative 1. Sn negative equal negative 1. MnO4 negative 1 equal negative 1. sulfate group equal to negative, carbonate equal to negative, so this S2O3 to negative equal to negative, Cr2O7 negative 2 equal to negative. Here PO4 3 negative 3 equal 3 negative. So any element with a charge equal the charge. If I tell you PO4 3 negative equals what, you will say equals 3 negative because it has a charge on it. Now we have some special cases, we spoke about it, like hydrogen. We said if it is here hydrogen positive, but here it will be negative. We have oxygen. Oxygen has cases, here it will be to negative, but here with an element which is more electronegative, it will be to positive. Here we have oxygen in peroxide. In normal cases, oxygen negative 2, but in peroxide, here H2O 2 negative, but H2O2 it will be 1 negative. MgO 2 negative, MgO2 it will be 1 negative. K2O, this is monovalent, it will be negative 2 because this took 2 of oxygen. But if you have K2O2, this will be negative 1. It will not be negative 2. So in the cases of peroxide, you will have the oxidation number of oxygen negative 1. Now let's start calculating some elements or questions in the ministry exam comes and gives you one element to calculate its oxidation number. In this case, it asks you to calculate carbon, the oxidation number of carbon. This is neutral compound, so carbon dioxide equals 0. Now we want to find carbon. We'll see X, carbon, plus oxygen, it is negative 2. Negative 2 times 2, it will be negative 4 equals 0. Now X equal, this will be after the plus sign, so it will be positive 4. What is the oxidation number of carbon in this compound? It will be positive 4. Let's see another example here. It said, what is the oxidation number of sulfur in this compound? Hydrogen is positive 1. Positive 1 times 2, it is 2 positive. Plus, this sulfur will see X plus. Oxygen is 2 negative times 4, it will be negative 8. This all neutral compound, so it must equal 0. 2 positive plus 8 negative, it will be X plus negative 6 equals 0. X equals, now this after this one will be positive 6. So what is the value or the oxidation number of sulfur? You will see it equal positive 6 in this compound. Let's see another example. If we have Cr2O3, now here we don't have X, we have 2X. So we'll see 2X plus oxygen negative 2 times 3 will be negative 6 equal 0. 2X equal positive 6 over 2, so 2 with 2, so X equals positive 3. In this case, chromium equal 3 positive. Let's see here another example. KMnO4. Now potassium is positive 1. Let's say positive 1 plus manganese. This one will be X plus oxygen to negative times 4 will be negative 8 equals 0. Now plus 1 and negative 8 will be X plus negative 7 equals 0. X equals positive 7. What is the oxidation number of manganese in this case? Will be positive 7. Let's look at another example here. If we have an ion with a charge, we will not see equal 0, we will see equal the charge. Here, manganese, I'll see X plus. Oxygen is negative 2. Negative 2 times 4, that will be negative 8. Equal 0? No, equal negative 1. Now X equals negative 1, and this we will send it to the other side. So with opposite sign, plus 8. Negative 1 plus 8, that equal positive 7. So what is the oxidation number of manganese here is positive 7 as well, like the one before. Let's look at these compounds if they have like brackets or whatever. If you have a bracket, this bracket will be for everything inside of it. If you have here element, it will be only for this one. If you have number before the molecule, it will be for everything inside after it. Now in this case it asks us to find the oxidation number of iron. In this case, let's see magnesium. Magnesium 2, it has 2 atoms and it is 2 positive magnesium, so that will be 4 positive. 2 times positive 2, 4 positive, plus here iron will be the X, plus Sn, it is a group which contains all of its atoms equal here, this one, Sn equal negative 1. So I will not calculate it like carbon alone and nitrogen alone. All of this equal negative 1. Negative 1 times 6, that will be negative 6, equal 0. Now 4 plus negative 6, X plus that will be 4 plus negative 6, that will be negative 2, equals 0. X equals positive 2. And this is the answer for iron. The oxidation number of iron in this case will be positive 2. Let's see if we have 2 groups here together, or if it asks you to find 2 at the same time, 2 elements. First we are going to deal with the first nitrogen, and then we'll deal with the second nitrogen. We'll find the value of the first nitrogen, then we'll find the value or the oxidation number of the second nitrogen. We know these are like groups, and NH4 equals positive 1, all of it. NO3, all of it equals negative 1. So let's first find this N. Let's see, X plus positive 4 of hydrogen, plus all of this we said will be negative 1, plus negative 1. I will not see X and this is negative 6. No, I will count it all as one group. All of this equal negative 1. So all of this group NO3 equal negative 1 equal 0. This is a neutral compound. So X plus 4 plus negative 1, that will be positive 3 equals 0. So X equals negative 3. The first N here, negative 3. We found it. Now let's find the second N. This nitrogen, the second N. We will deal with this all as one group which has one valence number, which is 4. Its oxidation number is positive 1. Now NH4, positive 1, 1 positive, positive 1, plus this N. Now I will deal with it as X, plus oxygen negative 2 times 3, that will be negative 6 equals 0. Now positive 1 plus negative 6, X plus negative 5 equals 0. X equals positive 5. Now the second N equals positive 5. The first one equals negative 3. The second one equals positive 5. So what is the oxidation number of nitrogen in this compound? It is negative 3 and positive 5. Let's see another example here. Ag is X plus NH3, all of it must be 0 because this is negative 3 and this is positive times 3, that will be positive 3. So all of this will be 0. 0 times 2, that will be also 0. X plus 0 equal negative 1. So X equals negative 1. Okay, let's look at some questions, how they could be in the ministry exam. It says, the highest oxidation number of oxygen is in the compound. Now it gives us compounds. Then we should determine the highest oxidation or the lowest oxidation number. In this case, magnesium oxygen. Here it is peroxide, so the value of oxygen is -1. Aluminium oxide, here it is 2 negative. Here oxygen OF2, in this case it comes the oxygen with fluorine, so it is +2, and in this case it is 2 negative. So what is the highest oxidation or number of oxygen? It will be the choice number 3, which has 2 positive. This is 1 negative, 2 negative, 2 positive, and here 2 negative. This is the highest. Let's look at another question. It says the lowest oxidation number of oxygen is in, this is peroxide, -1. This is peroxide as well, -1. This is also peroxide. This is here oxygen and fluorine. This is +2. And here it is calcium oxide, -2. Which one is the lowest? Is this one, -2. So what is the lowest oxidation number of oxygen? It will be in calcium oxide. Let's see here, question number 3. It says the oxidation number of hydrogen and oxygen are the same in which compound? Let's see. If we have HCl and oxygen, here H and oxygen are hydrogen and oxygen the same, this is +1 and this is +2. No, it is not the same. Here the hydrogen is -1, and in this case it is peroxide, -1. So yes, this is the same. In this compound, the oxidation number of hydrogen and oxygen are the same. Let's see, look at this one. The oxidation number of nitrogen in ammonia. In ammonia is more electronegative than hydrogen, so it will be -3, and hydrogen will be +1. +1 times 3, -3. So it will be -3. Now let's look at the oxidation number of iron in the compound Fa3O4. This, if you try to calculate it, be aware of this case. If you try to calculate it like the first ones, you will make a mistake here. Why? Because this is a compound which is mixture of Fa2O3 and FaO. The oxidation number of this is 3 positive and this is 2 positive. So what is the oxidation number of them both? It will be 3 positive, 2 positive. Do not calculate it like any element, because this has special case which is 2 positive and 3 positive. The answer should be 4. Number 4, which is 2 positive and 3 positive. We need to find oxidation numbers because sometimes questions ask us about which needs reducing or oxidizing agent. In cases like these, we calculate the oxidation number of all the choices, the elements and all the choices. The first one, manganese, was 2 positive, and the second one is 7. If you calculate it, x plus -8 equal -1. So x plus +8, that will be 7. In this case, it is +7. Now, from +2 to +7, what happened is oxidation. So did it need reducing agent? No. Let's look at the second one. What is the oxidation number of sulfur in this case and in this case? Okay, what is the oxidation? The first one, let's say 2x plus -6 equals -2. Here we will put it here. It will be 2x plus 2x equals -6 plus 6. That will -2 plus 6. That will be +4. So 2x over 2 that will be +2. The oxidation number of sulfur here 2 positive. Let's see the oxidation number in the after the arrow. Let's see, x plus -8 equal -2. X equals -2 plus 8. That will be +6. Now it changes from 2 positive to 6 positive. Now from 2 positive to 6 positive, what happened is oxidation. So here it is oxidized. Did it need a reducing agent? No, it needed oxidizing agent. Let's see the third one. The third one here, let's say Cr2, here will be 6 positive. We calculated before, it will be 6 positive. From 6 positive to 3 positive, what happened? A reduction. So, reduction. It is reduced, so it needed reducing agent. Yes, so the answer should be this one. If you do not understand questions like this, you'll calculate them all. You'll find this happened oxidation, oxidation here, oxidation, except this, the only one which happened to it, reduction, which needed reducing agent. And these are the type of questions which can be for such questions.